Okay, so this is going to be the new video series for the aw10 class. We're going to start off with chapter 2 as we just finished our measurement chapter. Chapter 2, much like last semester, we went over a lot of these before, so this will be a little review, which is nice. But we're going to talk a lot about graphs in chapter 2. There's 6 we're going to talk about. The line graph, a bar graph, circle graph, or sometimes called a pie graph, a histogram, which is different than a bar graph, we'll go over that why, a pictograph, which more or less uses pictures, and an infograph, which is some sort of way of giving you media or information in a picture. A lot of videos tend to be like this nowadays. So, for line graphs, we're mainly used when we're trying to display some sort of numeric data. More specifically, we're looking at broken line graphs. So a broken line graph will have points on your graph that highlight a specific point or between two data points, but they will be connected by a line segment. Okay? We usually want to explain what your two variables are. So most of the time you're going to have time of some kind on your bottom axis, your x-axis, and then whatever you're testing is on your left axis. It's good to label these and explain what it is. So this is a number of the times you went out of the house today, a number of times you went out of the house, and this is the day of the week. So the first day you went out twice, second day you went out 6 times, same with the third day, fourth day you went out 4 times. You can kind of see the progression as it goes. Line graphs are always used to compare two variables. Okay, a variable is just another fancy word for a thing. So really, you're comparing one thing to another thing. But most of the time, one of these is always going to be a time. When we look at our bottom graph here, there's a couple of really good examples we can think of. Some are good, some are less good. This is kind of a temperature versus time graph. So I have my temperature on my left-hand side here. And I've got the time of the day as my bottom variable. So you can see as the day progresses, going from noon until 8 o'clock at night, we start off at -9, we go up to about -3, and then we go back down to about -12 when the sun goes down. Part of graphs is really their ability to convey information to you guys. We care about your being able to create your own graph and interpret a graph. So interpreting a graph is if you look at a graph, can you gather data from this graph and give yourself or answer some basic questions. So if we were asked you for this graph to say, hey, when was it the coldest? You could say, well, at -12 was the coldest. It was coldest at 8 p.m. When was it the warmest? Well, -3, and that was at 5. When did we start recording for this graph? What was the first time we started? Well, that would be at noon. And something you can kind of extrapolate from this, or you could kind of guess at, is what season this is likely. Well, because it's, -9 to -12, -3, probably either late fall, midwinter, somewhere around there. So you can always gather and interpret data from a graph. You can always see trends of graphs, whether or not they're going up or down, and it kind of follows those lines. So as we saw, as the day progressed in the last graph, as it went up, it got warmer. We also then saw it progress down again. So you can kind of see the trends as we go along. We can use graphs quite a bit when we're given data and we want to display this or show it out. So what you've been given here is the population of Elk near Fort St. John. I made up these numbers, so they could be accurate, could be not. And we're given the year and the number. So in 1995, there was 3,000. In the year 2000, there was 3,500. In 2005, there was 4,500. In 2010, 3,000. 2015, 1,500. And in 2020, there's 2,500. When you're asked to graph this data, okay, it's good to pick nice even points that are evenly scattered the whole way. I wouldn't want to go like 1, 10, 3,000 and up. We want to make sure it's a nice even scale for both time as well as our variable. It's good to label your axes as well, so someone who's looking at your graph can then interpret it later on. So, in 1995, there was 3,000 elk. In 2000, there was 3,500. In 2005, we had 4,500. In 2010, we suddenly shot back down to 3,000. In 2015, we had 1,500. And in 2020, we had 2,500 again. To make it nice and neat, we can connect it with some lines. Like so. We're going to talk about two terms, interpolation and extrapolation. Interpreting data, really, interpolation is basically when you look at a graph and you're going to estimate a value that lies between 2 points in your graph. So if you're asked to find, what was the population of 2007, even though we didn't technically take that data, we know that 2007 is roughly there, and we could very easily take a bit of a ruler and probably have an estimate. Again, an estimate is an educated guess. It's not a blatant guess, but we're using some information to kind of back up our theory. But we could say it was roughly about 4,000. We're not 100% sure, but we're probably pretty close, right? But we're interpreting the data we have, hence interpolation, to figure that out. That is different than extrapolating data. Extrapolation is when you use a graph, but we're estimating a value that is not on the graph. So if we were to continue on and kind of look at our trends, even though we don't have 2025 on our graph, it would be safe to assume that if it followed the same trend, it would probably, again, be in that 4,000 range. So what we're basically doing is you're looking at the current data you have and extrapolating and seeing where it should go. And again, you could be asked to interpret information from this graph or critique it. How was this information gathered? Who reported it? If you were asked to interpret it, why do you think there are rises for 10 years up to 2005, and why do you think it suddenly dropped for the next 10 years, and then why do you think it went up? You'd have to be able to come up with some sort of reason for that. As long as you can back up your information and your theory, you're probably okay. Now, we haven't gone too far into this yet. I'll actually explain it to you guys more in the Google Classroom, but because most of you have the book still at school, or some of you don't have a book at all yet, what I'm going to do is only assign 2 questions per video. That's your only homework, but you do have to submit it within 48 hours of the video being posted. So, for your very first question, you have to draw an example of each type of graph that we mentioned in the very beginning, so there should be 6 in total. Please don't use the ones I gave, and they don't have to be that detailed. I'm looking for just a rough sketch, maybe label a few things. Question number 2, the more important one, is you have to graph, using a line graph, the data I've given you down here. This is the cost of heating. And again, I've made up some numbers, but I've given you a time frame, so the months between January to July. And so we have January, February, March, April, May, June, July. And for each of these months, I've given you a cost of heating. So you have 130, 140, 90, 100, 60, 30, and 20. I'm looking for a neat graph that has been labeled. Each of your axes are well spaced out, and preferably if you have it on lined paper. That's it. Good luck, guys.